Hello, and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering and related topics. I'm your host, Sean Faulkner, and today I'm joined by Anshu Sharma, co-founder and CEO of Skyflow, and we'll be talking about how the software industry has failed to deliver on the promise of cybersecurity. Anshu, welcome back to the show.
Thank you for inviting me back, Sean. I was always wondering if I'll get invited back on the Skyflow Partially Redacted podcast ever again.
I would hope as the co-founder and CEO of Skyflow that we might find time for you at some point. But you were actually the first guest that we've ever had. And if you're listening and didn't hear Anshu's first appearance, where we talked about privacy by architecture, you should definitely check it out. I'll include that in the show notes. But today, I wanted to dig into your thoughts on cybersecurity. So we had the RSA conference just about a month or so ago. And, we see companies have been, they spend a lot on cybersecurity, but it seems like despite the millions being spent, there's still, you look at Google News, there's tons of data breaches, there's ransomware attacks all the time. What do you think is going on here? Like, are we getting better at protecting customer data or are we getting worse?
Yeah, I think it's, in some ways, everything is getting more complex as a cybersecurity. I would say in general, people have gotten better, but compared to the amount of money we're spending, it feels insanely wrong that we have the number of data breaches that we do. Not a single day goes by before you hear a news headline that says, this health system here or this B2C company there lost people's social security numbers. So I think there's something structural that's off, and we'd love to talk to you about it. But I think directionally, society is moving in the right direction. If you haven't seen the latest Apple billboards on highways, they've replaced their Apple logo with an Apple logo with a lock icon sort of designed into it. Of all companies I know, in some ways, Apple has done a lot to convince people that privacy is an important requirement. That's gotten into the minds of brand managers and CMOs at other big companies. I'm hoping that feeds back into product and engineering so they actually don't just run billboards, but actually start doing something about preventing these breaches.
Mm-hmm. Yeah, I actually saw a billboard just on the weekend, I think from Soho, that was said choose privacy. So there seems to be, I think more and more companies looking at at least leveraging or trying to prioritize privacy as a product differentiator. But, you mentioned about that there was perhaps something structurally wrong with the challenges that companies are having. So, why, digging into that deeper, like why is it that the software industry started having such a challenge around, cybersecurity as something that's, essentially it's there to protect this information, but we haven't really been successful in that capacity?
Yeah, I think let me give you an example. Imagine if we had the car industry and then we had the seatbelt industry, right? And imagine if the car industry makes, $100 billion a year. We found out that the car safety industry was making like $0 and $1 billion and then $10 billion, $20 billion. And all car safety was sold as an afterthought. And so dealerships had to convince you on a one-on-one basis that you should get a seat belt and such. That used to happen, by the way. I remember growing up in India and seat belts were basically a luxury good till the laws changed. But I think something structurally is wrong if seat belts are not in your car. Similarly, if an email vendor is selling you email as a service and doesn't do the best job at protecting you, then what are they really selling? Basically, at this point, selling cars without seatbelts. So our view is there's a good reason why we started this trend out. Routers didn't have enough security features, so companies like Palo Alto Networks came out to do firewalls. Databases didn't have enough features, so companies like Data Domain started doing encryption on the pipe. But these were meant to be stopgap measures that ultimately fed back into the product so that instead of building products that are fundamentally insecure, fundamentally disrespectful of people's privacy, fundamentally architected to invade our lives. We need to move from that architecture to having products that actually think of privacy, security, and data protection first. And as long as we have these hundreds of tools that are sold as aftermarket seatbelts, I think something is wrong. That doesn't mean you shouldn't be able to sell cybersecurity products for things that you compose together, but at least, S3 recently added a capability, I think, where they default to like requiring you not to have it publicly available. Well, that should have been the case 15 years ago. What was the use case for having an S3 bucket that's openly available to anybody on the internet? Not many, right? So I think that's our view. I think we spend tens of billions of dollars at some amazing cybersecurity products, some of which we should have never built because they should have been seatbelts inside the car. Some of them could be better built because they're too cumbersome and too difficult, because essentially you're working with usually it's kind of like when you buy car mats and they don't fit in your car because they're not made by the same manufacturer. So I think our view is, look, there's going to be a certain set of problems that can only be solved in the context of a customer environment. So take, scanning for sensitive data is one of them. Having rules around who's your employee, who's not your employee will require things like Okta. But then there are other products that, in my opinion, should come with seatbelts included. And customer data management, in my opinion, is one of the top ones in that category. And so, that's the question I ask myself while working at companies like Oracle and Salesforce. Selling databases to primarily store like customer data, I would say in 80% of cases. And clearly companies like Salesforce were built to gather, collect, use, harness customer data. Why hasn't underlying technology been built in a privacy first manner so that as we are using the customer data, whether it's for workflows or analytics, or these days with LLMs and GPT, for machine learning models, the privacy and security and data protection is inherently built in?
Yeah, so you mentioned this idea of like the seatbelt, essentially. Like, do you buy a car that doesn't have seatbelt and you have to go buy the seatbelt from a different company, essentially, and add it in? Or in the software case, it's like you have your email software, and then you're buying essentially additional piece of software that you're layering on as a bandaid to make your email secure. And that is sort of like the fundamental problem. So it's just kind of the core concept here around that software should be built with like security by default. Like you mentioned the S3 bucket case, like by default, it should probably not be public. By default, essentially, your database should support probably certain layers of encryption, or that your email should be secure and sent over TLS. These types of decisions essentially should be done as a core sort of component of the product, of any product that we're developing.
Yes, so I think there are things that I would call the seatbelts. You shouldn't really sell email without, for example, two-factor authentication turned on, right? You shouldn't actually even use two-factor authentication without something like passkeys these days turned on. So the bar on what is considered a reasonably secure product they're shipping keeps increasing, and most companies should endeavor to do that. There's recently been a lot of talk, even at the government level with like Biden and such, where they're like, hey, can we ask companies to ship slightly more secure products, because there are some problems that inherently cannot be solved by the aftermarket products, right? Selling seatbelts you're not going to be able to embed the detector that can figure out if there's a child sitting there versus a grown-up. So, you have to, if you want to set seatbelts are amazing, it should also include sensors for body weight. It should also include, deployable airbags. So I think products should be fundamentally more secure. They should be built with privacy and data protection in mind. Apple's iPhone comes to mind. To ship a great payments product, they didn't just build an app. They also thought about it a little bit ahead of time and include a secure element. as one of our customers, Bo Hartman, who built the backend for Apple Car, talks about, the architecture itself is privacy first or privacy by engineering. So I think that mindset has to be adopted by the industry. And then I think there are fundamental problems that are still unsolved because it's not a matter of just adding a seatbelt. It's oftentimes about rethinking certain things. So you can't really add seatbelts to make a car secure if the problem is crashing and the frame of the car breaking down. You have to build a frame of the car that's fundamentally resistant to you rolling ever. So, or if you want to build an electric car, you have to rethink where the fuel lies. It's, as we all know, the battery pack is at the floor. I think in a similar way, my personal feeling was that it's very hard to build a data protection platform for customer sensitive data, things like social security numbers, credit card numbers, and even email addresses and IP addresses, if we just keep adding seatbelts. What we needed to build was go out build a Tesla of customer data platforms. And I think that's the attempt that Skyflow is making. We think there are novel new technologies available in encryption, tokenization, ways of governing the data, even ways how you use the data has changed. No longer is your customer service rep looking at the phone number at their desk. They're actually clicking on a button. Well, clicking on a button means they don't really need to see the phone number. It's connected to Twilio. Well, can we take advantage of that? So through our connections architecture, we're like, hey, 99% of the cases, nobody needs to see a phone number even while making a phone call. You experience this all the time with Uber's new features, which took them many years to develop, so that if you take a ride from the airport to your home, the Uber driver doesn't really get the right to start calling you next morning and saying, hey, you want to go out on a date with me? So I think that's the mindset. Can we take all the learnings we've had and think privacy first, data protection first, data sovereignty, which is the idea that for certain types of data, different countries and regulatory environments don't want their data leaving. There's some very bad political reasons why they want that, but there's also some good reasonable reasons why everybody would. Most Americans would not be comfortable with our, military's data being sitting in a Chinese server, for example, and that's kind of like the basis for the TikTok problems. But the inverse is equally true. Just because we have the powers to get a subpoena and find out data in somebody's server doesn't mean that's something that Germany and China necessarily want to enable for their citizens. So how do you solve these problems? You can't just add more duct tapes or add more seatbelts. You have to rethink the architecture. And so, reading lots and lots of new research, I spent about 10 years thinking about this problem since 2009 to 2019. And then it kind of came together, which is, hey, if we use multiple different encryption schemes and combine them in a very intuitive new way, we call this polymorphic data encryption, you can actually kind of have your cake and eat too. You can do all the things you want to do, such as access the data for a certain use case, find a customer, search for a customer, verify somebody's age, verify some information, actually make a phone call, and these days even do things like GPT and LLM without putting the data at risk. And that's been the journey, and it's been fascinating. And we don't think of ourselves as a cybersecurity vendor. We think of ourselves as core infrastructure. Just like you buy a secrets manager from Hashi, you buy an identity system from Okta, we think every company will end up having a data privacy vault, which is purpose-built bottom-up to handle sensitive data, because this data is fundamentally different.
Pardon the interruption, but it's me, Sean, the host, talking to you directly. I hope you're enjoying the episode, and if so, please subscribe and leave a positive rating and review. You can also join the Partially Redacted community at skyflow.com/community to make show suggestions, interact with me, other listeners, and privacy experts and enthusiasts. All right, now back to the show.
So I think, you've talked about this idea of essentially being able to use a lot of this customer data without sort of actually like seeing it yourself. And I think one example you gave was when you call your Uber driver, that call is going to get routed to the Uber driver, but you're not actually seeing the Uber driver's phone number at any point. So it's protecting essentially the privacy of their, presumably their home phone number. But I think this is like sometimes a tough concept for like people who've grown up engineering where they can just access the information. They kind of convince themselves like, don't I need this? Like, don't I need to get this record from the database in order to, perform this type of action? So, what is your sort of, thought process or recommendation for helping somebody with an engineering background kind of make this, paradigm shift or leap in thinking so that they're able to develop modern applications that are, taking advantage of the best practices around security and privacy, but still be able to do all the things that they're, used to being able to do for the last, 20 years with customer data?
Yeah, so I think common human intuition, even for engineers, leads me to think that if I want to be able to use something, I should be able to see something. There's very few things in my life that I can use like without being able to actually access them. It sounds so counterintuitive. But we've been doing things like this for decades now. They've just been in very specific silos and we don't think of it in this particular way. So let me give you some examples. Passwords, right? People used to actually store passwords in their databases and just match them. And, hence silly rules and laws and such. In fact, they used to restrict them to 8 characters because how it was stored in the database and such. So terrible idea. But then we decided, hey, you should hash them and salt them. What fundamentally it says is there is a certain very specific data type called password. It has only one operation called, did you get the password right? To see if somebody got the password right, we don't need to look up the right password. We just need to generate the same hash and see if it matches. If it doesn't matches, there is 1 in trillion chances that somebody can just guess that. So here is an example of a very specific data type that you can use it. In fact, our entire economy runs on passwords, but you can use it without. Similarly, we've been using credit card numbers for almost 2 generations now. And in the last 20-30 years, most credit card numbers are ideally, this is not always true, so it's still work in progress in some areas, but in most cases, your credit card number doesn't just go floating around as the known 16-digit number. It gets converted into a token. A token is just a representation of the data that's disconnected from the underlying data. Because the thing with tokenization is I simply want to be able to get it back when I'm processing the payment. So that's another example of a technique that you're using where you don't really see the data. You don't need to see my full credit card number for Bank of America to validate it. In fact, Apple went one step further and they said, even your software doesn't need to see it. They have a thing called the secure element on the chip that actually signs and creates one-time tokens. So we know that for passwords, for credit card numbers, for certain other data types, the simplest is if you want to prove you're above 21 years of age, you can actually show me your ID and cover up the exact DDMM, because based on your years of birth, I can actually usually tell whether you're 21 or not. So we also know that intuitively. The problem has been that the databases, the customer data platforms, and these technologies have basically relied on human intuition rather than these computational technologies that are readily available. Partly it was just practical, right? Who's going to sit there and think about how does a phone number behave like a password? Well, turns out your last 4 digits kind of behave like a password. And the first 3 digits, on the other hand, act more like a pointer, right? They tell you vaguely where you live. So we were able to combine these multiple technologies because now things are running in the cloud, compute is cheap, storage is cheaper. So we can apply multiple different algorithms. We call this polymorphic data encryption and tokenization, generate a token, which looks like what you think the data is. As a result, you can actually now do things without seeing the data. So the intuition is mostly right. Even now, sometimes it takes me like a few minutes to actually gather my thoughts around all of the things that need to be combined to make it work. But that's the only job we do, right? That's the only, just like Okta people wake up every morning and say, hey, how do we protect passwords? And people at Stripe figure out how do we increase the swipe rate for your credit card numbers. We wake up every morning and say, hey, if given a social security number, what are the operations? How do we do them? Where are they used? And can we build the core infrastructure so that you don't have to think about things like key rotation and backups and such? Because it's not just sensitive data, but it's also important data, right? If the data is not important, you can just throw it away. But turns out these attributes about us help us get coffee with oat milk. Starbucks can't give me oat milk coffee if it doesn't know who I am. It doesn't need to know exactly that my name is Anshu Sharma. It doesn't need to know my exact date of birth. But if they can identify me, they can serve me. And that's the dichotomy, right? Some of us whose names are hard to pronounce are already familiar walking in and telling the barista, hey, my name is just Sam or Andrew, or Andrew, by the way, is my Starbucks name, because that's what they usually hear when I say Anshu. But in some ways, Andrew is my token name. And it's sufficient for the purposes of ordering coffee, picking up coffee, and avoiding namespace collisions with other coffee pickers, unless there is another Andrew there. And that's the kind of thing that we worry about. When you're generating tokens, there's no namespace collision. So in real life, we are already familiar with using some of these techniques. Sitting next to somebody on a plane, you may just say, hey, my name is Sean. You don't need to necessarily identify that you come from a family of falconers. So I think not revealing your last name to somebody you meet in a bar, saying things like, hey, why don't you give me your phone number? I'll call you rather than call me. These are all the things that humans intuitively do to protect their privacy and data. It's just that the tech hasn't evolved to match up. And Skyflow's goal is to take these intuitions about protecting our privacy, combine them with the latest technology, and make it as simple as you find it to use in a product like iMessage or FaceTime, right? Enterprises need to be able to deliver pharmacy to you without having a team of 400 engineers thinking about how do I encrypt the last 4 digits of your employer's ID.
Mm-hmm. Yeah. So do you think the sort of like fundamental issue is that, outside of using something like Skyflow, traditional or historically, we're going to be storing probably this data in a database somewhere. And even if we're encrypting it, we essentially don't really have the technology tools built in that allow us to run the types of like workflows and operations that we would do on the data. For example, like only revealing the last 4 digits of the social security number or something like that. And that is essentially, if we don't have those tools built in, we either, put on a bunch of, sort of like bolted on solutions to try to fix that, or we end up having to decrypt that information at some point and then perform operations on it. And then that potentially exposes us and it, ends up in a log file or something like that. And that leads to this issue where we have a data breach or some sort of compromise.
Yeah. I mean, if you think about it, companies like Equifax were 100% compliant. They had all of their beautiful compliance certificates hanging. They had SOC 2, they had audits, they had best companies come in and verify everything. But a lot of cybersecurity is sort of like what I call compliance drama, right? Somebody made up some rules. As long as you document what you're doing, you can almost get away with anything. There's no rule in SOC 2 that I'm aware of that says your password can't just be monkey1 for every customer of yours. It may be considered bad karma, bad practice, but there's no rule that prevents you. So if you have the mindset of, hey, what's the least I can get away with so that my liability insurance covers it and I can say I was compliant, you lead to outcomes like Equifax, Marriott, Capital One, all of these things, bad things happen to fully compliant companies. The alternative to that is not that you just never use the data. Sometimes we're presented with this false dichotomy, right? Which is, hey, either, I remember Mark Zuckerberg famously saying like, privacy is over, get over it kind of a thing. And the reality is it's not true. He himself bought 4 homes around his house so he could have some sense of privacy. That's important, how privacy is. So I don't know how many homes our viewers here, listeners have bought for privacy, but definitely not 4. So that tells you the value that we attach to privacy. It's just that the tools are crude. Buying 4 homes, frankly, is a terrible way to protect your privacy. There are better, more modern techniques available. It's just that we need to do the work. And the work is quite intense. It requires to be thoughtful. And the work needs to be tied back to what's possible. At the end of the day, what do you as a CEO want, or CTO want, or CISO want? You want to be able to define a policy and be rest assured that it's actually being followed. Putting the burden of making sure every application developer, every database developer, every API developer, every UX developer fundamentally thinks through all the consequences of data privacy, data protection, data sovereignty is frankly just insane. There's no other field where we rely on the average person to do all the things right, because one mistake can ruin it all. So I think that's why SaaS and cloud as a model have worked out. None of us want to tune our databases anymore. None of us want to write our own query managers and query processors. We want AWS, GCP, Snowflake to take care of things. Similarly, it's kind of insane that it's 2023 and 99% of companies in the world rely on their engineers doing all the things right, rather than giving them core infrastructure so that they can protect sensitive customer data from day zero.
Yeah, and I would say like if you look at something like databases, the one, like the amount of data that we're storing now, the scale of it, everything's just more complicated. So if you're putting essentially the responsibility of all the database tuning on essentially like someone who's not an expert, like you're not going to lead to good results. I recently saw a tweet by Kelsey Hightower, a very famous Google engineer, talking about how he doesn't like this, complete like shift left movement. Basically his perspective is like, we're putting too much responsibility on application engineers to know, like they shouldn't have to be security experts essentially in order to solve these types of problems. I think that's kind of, in the spirit of some of the things that you were mentioning there. But for the companies that are, looking to essentially build products with this mindset or approach of security and privacy by default, does that require sort of a different way of like running a company from like a cultural perspective, or a different type of way of hiring and thinking about building products?
Yeah, let me take the first part first, the Kelsey Hightower objection. I think he is right. Moving the burden left can be sometimes more detrimental than better. But the answer is not moving it right. The answer is actually moving it way to the left, so that by the point that application developer gets involved, there's already the right architecture in place. Just like we don't rely on application engineers doing the right thing when they want to use auth, or whether they want to use HTTPS or certificates. This is core internal platform that every company should have. And I think that's the answer. The answer to not moving left is not moving left. The answer to not moving left is actually to take care of it even before the application developers left starts. So that's one part. I think to your question around thinking differently, I think it takes a commitment to data protection, data privacy, data security. Every company is going to evaluate it differently. Our job is to make it dead simple, easy, so that you can define the policy and use it. I think thoughtfulness, whether you're building your business model or your security model is always important. So I think the key is actually thinking about it. And the way I think about it is, instead of coming back to our initial topic, instead of thinking of what are all the subsystems I have and what are the 14 tools I need to buy to protect, this field in these 14 systems, you want to step back and say, hey, why am I collecting any information? What's the reason for collecting somebody's social security number? If you're a company like Uber for ride sharing, or if a company like E-Trade or Morgan Stanley, it may be for KYC. But KYC last process takes about an hour. Sometimes it takes a month at most. But you've just created liability that's lifelong, poses a risk both to the end consumer, but also creates liability risk for companies. Companies have increasingly realized that not all data is monetizable. Some of it is fundamentally illegal to monetize. The other type of data is so high risk that you don't want to. And then even the data that you do need to monetize, you want to be careful so that actually you can preserve your ability to do it. So I think it does require fundamentally different kind of thinking. I think thankfully all the leading companies from Apple and Google to even the Facebooks of the world are beginning to talk about privacy as the core of their offering. It's kind of amusing sometimes to look at those WhatsApp billboards that say, hey, if you want privacy, first use a Facebook product. But that's where we are in the cycle. We've gone from not just leaders like Apple doing the right thing, but all the way to companies like Meta saying, hey, we're going to basically change the way we do business, because without that, we can't keep and retain the trust of customers. So even the most cynical CEO knows that if a customer doesn't trust them, they're not going to share information. If they don't share information, they're going to go do business with somebody else. So those are the, sort of capitalistic reasons to do the right thing here, other than moral imperative, which I think is also worth considering.
And what about for, the startup founder, small team, they're just building their initial product. There's so much to be thinking about in the early days of building a product. You're worried about how do we actually get customers? How do we build product market fit and so forth? So it's easy to, not really be thinking about the protection of customer data, or something that hey, once we have customers, we'll actually be thinking about this. So, what is your sort of advice for people who are building those early stage products to make sure that, this doesn't become essentially a big problem down the road?
Yeah, I think it's easy to do the right thing from day one these days, right? You have to be really insane to go out and build your own auth when it's as simple as dragging and dropping 4 lines of JavaScript code from a customer company like Okta or Dscope. Similarly, you would be insane to say, hey, for now, let me just do the credit card thing myself instead of getting it processed by Stripe or Checkout. I think in a similar way, companies like ours have made it easy to do the right thing. We have some programs for startups to do that, because we understand that some startups are pre-revenue, some startups are pre-code. And we tailor our programs and startup initiatives so that you can do the right thing. And for less than the cost of 1/10 of an engineer or even 1/20th of an engineer, you should be able to get started with the right model. And as you grow, we grow with you. So making it easy for customers to get started with the right model is a priority for us at Skyflow. But even if you choose not to use Skyflow, I think applying the principles of privacy engineering, privacy architecture are important. We make it easy so that, literally for a few $100s, you can get started with the right architecture. But let's say you don't even have that and don't want to apply to us to waive it for you. You can architect it in such a way that you are ready to take on the right thing. So let's say again, it's a terrible idea I hate to even say it, like, but if you do decide to hash and store your own passwords, if you do decide to hash and store your own social security numbers and credit card numbers, do it in a way that it's API first, and so that as you go beyond, gimmick prototypes and your first round of funding. I was talking to a founder just last week, and she's building an amazing app for women's health. She comes from the healthcare industry, and she's like, look, there's nobody telling me to do the right thing, but I feel it's wrong to take somebody's data and not protect it from day one. It's also damaging to the brand. Investors have gotten smarter too, right? If you're building a company today, investors ask you these questions, and there's also regulatory risk, right? What was PII used to be just social security numbers, then became email addresses and phone numbers, and today even your Apple device ID is considered PII according to most Europeans. So do the right thing. It's easy, it's simple. And if you want to do it yourself, we have a couple of videos that Sean, you've recorded sessions and such, like you could hack your own for a while. But we would love to talk to you and see if we can make it painless and easy so that you don't really have to do that.
Yeah, and you were mentioning about like investors getting smarter. I imagine also, if you're building a company and there's an acquisition on the table at some point too, those types of things are going to come up as well. They're going to be digging deep into like, how are you storing this data? Are we essentially taking on a tremendous amount of liability by adopting this, software system that you created? So, kind of looking ahead in the next few years, how do you see the software industry evolving in terms of cybersecurity, and how do you think companies like Skyflow will play a role in this?
So I think the software industry is waking up to the problem of aftermarket car mats and seatbelts. Microsoft has been selling these E3, E5 packages on top of email. They charge you a little bit more money, but at least they have now stepped up to try and protect you. At the same time, I think there's some gimmicky stuff like, frankly, a lot of confidential computing stuff is a little bit around, hey, in theory, the data is always protected. It can be useful for things like key management stuff, but frankly, some of that is gimmicks. But you see the change in the tone, right? We're recording this on the 12th, and Salesforce just had their Salesforce AI keynote today. That's a company known for talking about features, functions, demos, and prototypes. And Mark Benioff started his commentary about how enterprises will adopt GPT and LLMs by talking fundamentally about trust, privacy, and data sovereignty. So I think customers are demanding it. Customers are demanding from companies, so those companies are demanding it from their vendors. And we're all realizing that in order to implement it the right way and think about it from an engineering and architecture perspective, rather than band-aids and duct tape, at the end of the process, we have to do it the right way. And I think there's appetite for both vendors to start doing more of it, and customers are frankly just demanding it. They're no longer going to buy products that are fundamentally full of gaps and holes in the shape of cybersecurity.
Yeah, and, I guess, looking ahead for Skyflow, what's next? What are you excited about that's coming up for Skyflow?
Well, I called Skyflow a zero pivot company. In 2009, I initially thought of the core idea. It took me many years to actually find the right co-founders, the right team, the right technologies, so that we could piece the parts together. But I think we've taken on a core mission, which is how do we protect your privacy while enabling you to do business with each other and with businesses. I think that doesn't change. I think that's easily a 10-year journey. I could imagine it going longer. I think what that means for us is as the landscape changes, so, even just 4 or 5 years ago, it was all about data protection. A couple of years ago, people started using way more machine learning, including predictive. So customers of ours like IBM use us in the context of protecting the data in the context of machine learning. as you know, we announced our GPT Vault. That's the new thing. My suspicion is we are going to basically continue to see more and more use cases where privacy, data protection, and data sovereignty is going to be at the heart of it. And our goal is to make it easy to use Skyflow in those contexts. There's a second side to Skyflow, which is, hey, how do we do more out of the box integration? So today we have a whole collection of libraries. You can build your own too. But can we do even more so that it's even more seamless for customers to integrate this into their environments? And the third is the cloud partnerships. We've been partnering with AWS for years. They become a great partner to us. Other cloud vendors like Microsoft, GCP, even Alibaba are getting traction, lots of geographies. I think that you're going to see some traction and announcements as we make progress there. But my view is the privacy cloud is here to stay. Companies demand privacy be built into the products, whether the product might be cloud, might be your data platform, it might be an app, or it might be as silly as you sending out invitations to your friends. I think as people understand the value, people will demand more, and our job is to make it easier so that the application developer can shift left with privacy. But by the time they touch the leftmost function, it's already prepackaged, and all they have to do is define the schema and start using it.
Yeah. I remember when we were first talking about me joining Skyflow, my response was, and one of the reasons I was excited about it was that as somebody who's, engineered systems for years, I was like, I don't want to have to deal with this stuff. I want to have fun. I want to, build games. I want to build stuff that is core to my business. I don't want to have to, figure out and navigate things like PCI compliance, HIPAA compliance, GDPR, and so forth. So I think that this is a fantastic way essentially for anybody who wants to build tools and products and games and things like that to focus on the things that they enjoy rather than having to navigate that complex space. Well, Anshu, I want to thank you so much for being here. Thanks for coming back. I'm glad that we were able to do this. And until next time, I'm sure we'll have you on a third time.
Thanks, Sean.